Hi folks, welcome back to the fifth and final part in the 7.2 Law of Cosines. And so we're just going to finish off with some extensions of what it means to find area of a triangle, okay? So I feel like we all know that the area of a triangle, if anybody asks you, you're like, oh yeah, 1/2 base times height. But there's something very special about this because the base and the height, they have to be perpendicular to each other, okay? And if this is not the case, then you can't use this formula. Well, it turns out that just like for the Pythagorean theorem and law of cosines, how they're kind of extensions of each other, and then SOHCAHTOA has like the law of sines, that's the extension. We can extend and find an area formula for a triangle where it doesn't have to be a right triangle, or you don't have to know that the base and the height are perpendicular. Okay? So it turns out that for any triangle, right, so let's get that, our very generic triangle up here, it's oblique, it's not right. We could have A and B and C, all right? It turns out that if you find, let's say, little a times little b, right? So we've got little a over here, little b over here. And it kind of looks like that 1/2 base times height, but we might not know that A and B are perpendicular. Well, it turns out that to compensate for that, we're really doing AB times sine C. So whatever angle is in between A and B, if you multiply the sine of it to the area formula, then you'll get your area of a non-right triangle. Now, just like law of cosines has 3 variations, you can do the same thing with this general area formula. So I could take 1/2 b times c, and then I just do sine A, or the third angle. Or I could do 1/2 a times c and sine b, okay? So all 3 of these variations work, and again, that sine c, sine A, sine b make it the general formula, and you don't have to know that the base and the height are perpendicular. Okay, so base and height are not perpendicular. Okay. All right. Now, there is another formula for, let's say that we have a triangle, okay? So let's say we have the same kind of triangle, but this time we don't know any of the sides, or any of the angles, I'm sorry. We only know the sides. So we only know little a, we only know little b, and we only know little c, okay? Well, it turns out that just like there is a perimeter of a formula, of an area of a shape, okay? So perimeter of this shape would be A plus B plus C. But if I take that perimeter and I cut it in half, I have something we call S, and S stands for the semi-perimeter, okay? Now, if we want to find the area of a triangle and we only have the 3 sides, then what we can do is use the semi-perimeter to help us out. So we're going to take the square root of the semi-perimeter times s minus little a times s minus little b times s minus little c. And if we apply that formula, we'll be able to find the area of the triangle without knowing any of the angles in there, okay? Okay, so let's try a couple examples. Example 1, let's draw this out, see what we get. All right, these numbers should look familiar because these are actually from a different problem that we did earlier. Okay, we got 41.4, 2.78, 3.92. Okay, now I look at this and I'm saying, okay, this looks a lot like this side angle side. So I'm going to go ahead and use the general area formula. So the general area formula says I can have 1/2 times one side times another side. But if I'm not sure if they meet at a right angle, I need to multiply it by sine of the angle in between them, and that will take care of the fact that it's not a right triangle. So 1/2 times 2.78 times 3.92 times sine 41.4, and that's going to give me an area of 3.603 square yards. Okay. All right, so let's take a look at this second case. And this looks like a great situation to use Heron's formula. All right, the one with the semi-perimeter. And again, I know that because I have one side, I have another side, and I have the third side. Okay, so I want to find that semi-perimeter first. I'm going to add up all the sides, and I'm going to cut it in half to get the semi-perimeter. And when I do that, I get a semi-perimeter of 66.5 feet. Now that's not my area though, because to find the area, I need to take the square root of S times S minus A times S minus B times S minus C. And that will give me the area. All right, so let's plug this all into our calculator. And when I do that, I get an area of 651.43 square feet. Okay? So let me zoom back out for a moment. All right, this last video was really just about finding the area of a triangle when you don't know that the base and the height are perpendicular, or if you don't have any of the angles inside. Okay? So that's a wrap for 7.2. If you have any questions, shoot me an email, send me a message, and I'm happy to help you out. All right, thanks so much. Bye.